A 200 gram stone is thrown vertically upward with an initial velocity of 10 meters per second from a starting point of 1.2 meters above the ground. A. What is the potential energy of the stone at its maximum height relative to the ground? B. What is the change in potential energy of the stone between its launch point and its maximum height?
Okay, so after carefully reading and analyzing our problem, we're gonna proceed and write down our data, which is the first step you should always follow when solving problems. Firstly, we have that the mass of our rock equals 200 grams. These we have to convert into kilograms, and we were left that with the information that the rock is 0.2 kilograms. Then we have the velocity initial that according to this problem is 10 meters over second. We proceed then to write our height u, which would be the point in which the rock was originally launched. This is of 1.2 meters. Our height tree is an incognita. We need to find this in order to solve the problem. We will proceed on writing our height 1. This is ground level, so it's obviously of 0 meters. And to solve our problem, the question A asks for the potential energy. And to solve question B, we need to find the difference in potential energy. Okay, so we will now write the formulas we're gonna use to solve this problem. We're gonna use 3 specific formulas. First, we're gonna write a formula that will help us determine the height tree, which, as we said on the data, is an incognita. The formula we're gonna use is 2 times gravity times y equals final velocity to the square minus initial velocity to the square. The second formula is to find the potential energy, and it is potential energy equals mass times gravity times height. And to find the difference or the change in potential energy, we will use the formula that is the difference in potential energy equals final potential energy minus initial potential energy.
So here's our sketch. We draw first the initial height, which is 0 meters. And then this is y, a distance we have to get in order to get the maximum height. And we plug in that our final velocity is 0. And the initial velocity is 10 meters over second. And it's 0 because at the top of any thrown object, the velocity will be 0 at the top. And then we plug in that our height given is 1.2 meters. And here's our third height, which is going to be the maximum height.
First, we will ask the potential energy of the stone at its maximum height relative to the ground. So, we will use this formula. But before, we need to find the maximum height. So, to find that, we need to find y. Like in this case, y is only this distance, and we were given 1.2 meters. So, height 2 plus y will be the maximum height. So, first, we will clear y. So y is equal to final velocity squared minus initial velocity squared divided by 2 times gravity. So all this data, we have it, so we only substitute. So we put these numbers in the calculator and the result is 5.1 meters. So now with y, we can find the maximum height. That will be h2 plus y. And this data we have it. We substitute, that is 1.2 meters plus 5.1 meters. And this is equal to 6.3 meters. So we have the maximum height, and now we can solve the letter A.
Okay, so now we can calculate the potential energy with the formula because we have the maximum height. So we put the formula, which is potential energy is equal to mass times gravity times height, and then we substitute with the dynamic levels. So it's mass kilograms times gravity 9.80 meters over second square, and times height, which is this one, so it's 6.3 meters. And the result is 12.36 joules, because the potential energy as well as the kinetic is measured in joules. Okay, we're asked to find the change in the potential energy, which is delta V of E. But in order to find this, we need to find the other potential energy value initial. So it's potential energy initial. It's equal to, we're going to use the same, of course, same formula. It's 0.2 kilograms times 9.8 meters over second square times the height, 1.2 meters, the given height, of course. So once we've got this in, the result is 2.35 joules. That is our initial potential. Now to get this one, we get that it's potential energy, the final, minus the potential initial. So we're going to substitute this one. The final, which is this one, 12.36 joules minus the initial 2.35 joules. So, and we get that delta EE is equal to 10.01